Okay, PEMDAS, PEMDAS, refers to the first letter of each operation, essentially, or the order in which you need to complete a problem. Now, this should be noted here that when we talk about parentheses, we're talking about any grouping symbol. What we're looking for is the innermost grouping symbol. Those grouping symbols could be parentheses, like are shown in this example right here, but you could also see grouping symbols that are square brackets, and you may also see curly brackets. Okay, but just start with the innermost grouping symbol and then work from the inside out, essentially. So let's take a look at how we can apply this. Whenever you are given a problem to evaluate, what you want to do is you start by looking for any grouping symbols, or in this case parentheses. And what it says is start right inside here. Now, it doesn't mean you automatically do what's the first thing that's in there. You have to then follow exponents, multiplication, division, addition, subtraction with inside that grouping symbol. Now, inside this grouping symbol, we only have a subtraction problem. So we don't have to deal with exponents or any of these. We can just do the subtraction. So your work is going to look like this. And we just do one step at a time. 5 minus 3 is 2. So the problem looks identical except for we've replaced or simplified this 5 minus 3. Now you'll notice we still have a set of parentheses. This parentheses is different than this pair. This pair indicated, hey, do this stuff first. This pair, since everything is completed inside the parentheses and it's bumped up against the number, this just means multiplication. They could put a little dot right there to indicate multiplication, but we generally don't show that just because it's easier to leave it out. So a number bumped up against parentheses like that does imply multiplication. So we've done the first thing. We've worked inside the parentheses. We've done everything we could. Now we have to deal with any exponents. Well, here we've got a 4. That 4 is squared, so that's 4 times 4. So we continue to work the problem, and we'll change that 4 squared to a 16. Next we evaluate again and look at it, and we say, okay, I've dealt with all my exponents. Do I have any multiplications as I work from left to right? And I certainly do. That's at 16 times 2. So we evaluate that. 16 times 2 is 32. I then continue to go through my Pemdas here, and I look for any other multiplications or divisions. Oop, got a division right here. So I continue to work that. 32 divided by 4 is 8. And then lastly, I end up with 8 plus 3, or 3 plus 8, 11. One thing I would like to note here is notice how the problem works down in this kind of triangular fashion. That's how your work should look. Don't work horizontally on your paper and write stuff this way. Instead, work downward, simplifying things and making the problem smaller as you go. Now, if you're good with order of operations, that's awesome. You don't have to watch the rest of this video. But if you'd like to see some more examples, I do have several of those for you to continue to look at. Here's an example of why we need to use order of operations. I've got a wrong example and a right example, a correct one. Okay? What I'd like you to know is they're the same problem. Now, if you do it incorrectly, someone who is not a mathematician and doesn't know mathematics, they would just go, oh, that's 3 plus 4. 7 times 2, which is 14. But this is incorrect. They did not follow order of operations. When you do order of operations, multiplication takes precedence over addition, so you would have to do any multiplications first. Notice in this case I've used the dot notation, this little dot right in the middle, instead of using the X for multiplication. This is much more common. This problem could also be written this way. Okay, it means the same thing, or in younger grades they would actually put the multiplication symbol. Okay, but you would see more commonly this or this in mathematics. So let's now go ahead and apply order of operations and solve it the correct way. We'll cross out this wrong method where they added first. You multiply first. 4 times 2 is 8, and 3 plus 8 is 11. Again, notice this nice inverted triangle that we get there, going from the more complicated expression down to the simplest answer for it. Next example, again I've written it here with the multiplication symbol, but you would probably see this more commonly. And we'll do our multiplication first. 2 times 6 is 12, and 3 plus 12 is 15, giving us again that inverted triangle down to our solution. Here we've got grouping symbols, the parentheses, so we have to do what's in there first. So it give us 3 plus 6, 9, times 2, which is 18. In this next example, we've got division there, multiplication there. We just work from left to right. So we'll do our division first. I'll move that over just a little bit. 6 divided by 3, 2. 4 times 2. I can do my multiplication next, and then lastly my addition. Similar problem. I've got some multiplication, I've got division, I've got subtraction here. I've got subtraction there as well. Okay. Some students have a hard time dealing with this minus sign. The way I look at it is just ignore that minus sign. This is just 12 divided by 3. And you want to subtract whatever that is. So let's work left to right, and I'll show you how that looks. First we do multiplication, 24. Again, I'm doing one step at a time. Then I'll do the division. 12 divided by 3 is 4. Notice I just kept that minus sign. Now I just work left to right. 24 minus 12, or 24 minus 4 is 20. And then finally 20 minus 8 is 12. Next example, again working left to right, I just have multiplications, divisions, and a couple of subtractions in here. I'll do my 4 times 4, 16. Next, the furthest left, I should say, is this multiplication that I have to do. So I go 16 minus 3 times 3 is 9. Next, I do this division. 16 divided by 4 is 4. Then I just keep going. 16 minus 9 is 7 minus 4. And then 7 minus 4 is 3. Okay. Now, because you'll notice I did this, I did that first multiplication. I did this first, then I did that, the next multiplication, then division. You could actually do this in a few shorter steps, or at least a little bit less writing, because the same thing could be accomplished by going 4 times 4 is 16, 3 times 3 is 9, and 16 divided by 4. And it jumps you directly to this line right here, just by working left to right and writing down the result as you work. 16 minus 9 again is 7 minus 4, and that gives you 3. So there's a little bit shorter work if you do multiple steps in each line. Example, I don't know, 8 or 7 here. Let's start inside the parentheses. Boom, boom. And inside the parentheses, we have to do exponents first. Pemdas, parentheses, then exponents. So it's 3 times 2 cubed. You can run off to the side and do that if you need to. Just means 2 times 2 times 2. I'm still working inside my parentheses, trying to clean that up. I have to do multiplication first before subtraction. Still working inside the parentheses. 24 minus 5, 19. And finally 20 minus 19, 1. Just take your time with it, and you'll be able to get it every single time. We have grouping symbols here, these parentheses. So we're going to work inside there first. That's a 7. You could leave the parentheses if you want to. It just indicates that's one group. Now I have to deal with exponents. I'm going to start from left to right. So I'll go 7 squared 49. Now again, I'm just going to do one step at a time to emphasize how order of operations work. I look at the new problem. I go, gotta deal with an exponent first. So it's 49 minus 9 times 3 plus 8. 2 times 2 is 4 times 2 is 8. Next, I'm going to deal with this multiplication. 3 times 9 or 9 times 3 is 27. Working left to right, I just have to do a little subtraction problem. 49 minus 27, which is 22. And lastly, my addition. Again, you'll note that triangular or inverted triangular shape as I simplify my problem. Again, inside parentheses, inside these first set, or this first set, I have to take care of division first. 12 divided by 3 is 4. I can work inside this separate set. I have to deal with this exponent first. 16. Working inside my parenthesis on the left-hand side, that's an 8. This second parenthesis, I've got 16 minus 6, but I got a multiplication, so I have to do that multiplication first. 6 times 2 is 12. Working inside those parentheses, 16 minus 12 is 4. Leaving me with 8 minus 4, or 4. 2 examples left. Note here we're using the slash for a division instead of a division sign. You could also see this written as follows. This would be the exact same problem. Note when it's written as this fraction, we don't show grouping symbols in the numerator or the denominator. There could be some, but we don't have to group the entire denominator or the entire numerator. When you write problems as fractions, it is automatically assumed that this is all grouped together in the top and grouped together in the bottom, the denominator. So let's go ahead and work this. I'll start with the top group, 5 squared. I have to take care of that squared first. I'll simplify the denominator separately, which means take care of the exponent, 4 squared. Still working in the numerator as a group, 25 minus 5. I'm going to switch colors here so you can see it a little bit better. 25 minus 5 is 20. In the denominator, I'm going to take care of this multiplication first. So I've got 16 minus 8 minus 7 times 2. I can't do any division yet. I just work left to right in the denominator. Let's do this all together here. 16, take away 8 is 8. And 8 minus 14 is negative 6. And then finally I can do my division. Well, 20 is not divisible by 6, but it can be simplified. Both divisible by 2. So I can write it as 10 over negative 3, or negative 10 thirds. And so I'm done right there. Hopefully they'll get you warmed up in remembering order of operations and how to use Pemdas. Example, that was it.